Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness, excuse me, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Counting to 7 by Zeta Math. And here are the rules. We have normal Sudoku rules apply. Excuse me, which means in every grid, every cell in the grid. Wow, I don't know what's going on there. I knew what I wanted to say, but it just wasn't coming out the right way. Anyways, in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have Renban lines, where digits along a Renban line must form a set of non-repeating consecutive digits in some order. So, for example, you could have something like, say, 3, 5, and 4 here, and that would be valid because 3, 4, 5 forms a set of non-repeating consecutive digits. And what we could not have is something like 3, 6, 4, because 3, 4, and 6 are not consecutive. So that doesn't work for that set. And that's an example of how Renban lines work. We also have numbered rooms, where a clue outside the grid indicates the digit which has to be placed in the nth cell in the corresponding direction, where n is a digit placed in the first cell in that direction. So they say this actually was a 6 here. Then this would have to be 2, because this would be saying 6 has to be in the second position in this direction here. And that's an example of how numbered rooms works. And those are all the rules. I'm not really sure why it's considered counting to 7. Maybe we'll see in this puzzle. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. In box 1, we have 3 sets of Renban lines. So they have to be 1, 2, 3, 4, 5, 6, and 7, 8, 9. Because every digit in this box is part of a 3-length Renban line. 1 can only be with 2 and 3. 9 can only be with 8 and 7, which means this must be low, mid, and high sets. So we can color them all different sets here. So we have 1 low, 1 medium, and 1 high in each of these columns. That's interesting. So we are guaranteed to have 1 low, 1 middle, and 1 high digit in column 2. We have another Renban here and another Renban here. If we try to have the middle digit, say we try to have 2 middle digits in the same say we try to have a 4 here. That would force a Renban of 1, 2, 3, and 7 with 5 or 6, or 7 with 8 and 9. But because of the 1, 2, 3 as a Renban, that would eliminate a low from any digit in column in this box. But we are guaranteed a low digit here, right? Because these must be 1, 2, 3, 5, 4, 5, 6, and 7, 8, 9 in some pattern. But that means we're guaranteed 1 digit here from 1, 2, or 3. So we cannot have the 4 being here, because that forces 1, 2, 3 to be one of these Renbans. And the same problem is with 6. So therefore, these Renbans have to be 2, 3, 4, and 6, 7, 8. Because we cannot have all the same set, all low digits, 1, 2, 3, all high digits, 7, 8, 9 is eliminated because we are guaranteed one of each in these cells here. So this must be 1, 5, and 9 here, which means 1 cannot be any of these digits here, or any of these digits here. 2 is either in the second part of the Renban or the last Renban. It can't be part of this. So this cannot be 1. It's 5 or 9. Which means 2 has to be either here or here. So if 2 is here, then this becomes a 3, 4 pair. Otherwise, 2 is here, which forces this to be a 3, 4 pair. And the remaining digits can be 6, 7, 8 as throughout. Okay. 1 cannot be 1, 2, or 3, so this must be 4 through 9 here, cannot be 5 or 9. If we had 1 not be in one of these, say we had 1 in one of these 3 cells. If we had a 1 there, the problem is that we would guarantee 1 in box 4 would have to be on this Renban. But the 1 has to be with 2 and 3 then. And that would eliminate a low digit here. And we know one of these 3 is a low digit guaranteed. So 1 cannot be on this Renban. 1 has to be one of these. So this must be 1, which means 4. This is equating to 4 and 6. So this is 4, 6. This must be 5 then, which makes 2 have to be there. So this is 2, 3, and 4 here, which means this can't be 2, 3, or 4. It's 6, 7, 8 here. These cannot be 5. It's 1 or 9. This is 4 and 6 to be here. That means 6 in these rows cannot be in 7, 8, or 9. So they have to be from 1 through 6 here. And they cannot be 6 because they're saying 6 would have to be in the 6th spot, but we already have a 6 in the first spot, which is not allowed. So 6 has to be in 1, 2, 3, or 4 and 5 positions here. Okay. This is a Renban. It cannot be 7, 8, and 9. This is 6, 7, 8. That eliminates 6, 7, 8 in the rest of the box. So we have 1 through 5 here and 9. But these can't be 1 because of the 1 in the column. Now we know one of these is a low and one of these is a mid. We're not sure which is which. These are all mid. This is a low. This is a mid and a low. So this cannot be low here. So this is low, a mid to high. So it cannot have 2, 3, 4. So this is guaranteed to have a 7 here. Which means where is the 7 in column 1? Cannot be here because of the 7 guaranteed here. Because it's either 5, 6, 7, 6, 7, 8, or 7, 8, and 9. Cannot be 7, 8, 9. So this has to be 7 and 6 here. So this is 5, 6, 7, 6, or 6, 7, 8 here. Because it can't be 7, 8, and 9 here. Because that would eliminate all highs in the rest of the column, but we are guaranteed a high here. So this cannot be 6. It's 4, which makes this 6. There's no more 4 here. 6 and 7 are here. Where is 7 then? In column 1, it must be one of these 2, which means where is 8 to make sure that this works as a Renban line? It would have to be 7, 9, 8 here. So one of these 2 is an 8, which means this cannot be 6, 7, 8. It's 5, 6, 7. So it's 5, 6, 7 here. This is 1, 8, 9 here. 1 has to be in the 6th spot, so that's 1. These cannot be 1 here. This is 8, 9 as a pair. That eliminates 8 and 9 in the rest of the column, so this can't be 9. So this is 7 with 2 or 3 here, and this is 8 with 2 or 3 here. So this cannot have 5 here. because of the 5, 6, 7 triplet in the column. These have to form a Ren band. And if this were 9, this would have to be a 7, 8 pair. But that's saying 3 would have to be in the 7th, 8th position in this column and the 7th, 8th position in that column. And that is not allowed because they would be in the same box and there would be a repeated digit in the box. So this can't be 9. 8 similarly cannot be 1. So this must be 2 or 3 as a low. Therefore, this must be low and middle. And it cannot be 1, 2, 3, because then that would force 3s to be in these cells here in these columns. So this has to have 4, and it cannot have 4 and 5. So this has to be 2, 3, or 4 here. So we're guaranteed 3 has to be one of these 2 digits here, which means this cannot be 3. So this is 4, which makes that 3. Because this 4, we have 2, 3, 4 as a triplet here also, because this is the only way this can be function for the numbered rooms clues. So this can't be 2, 3, or 4, it's 5, which eliminates 5 in the rest of the box. So we either have 3 cannot be here, because if 3 were here, it would basically say 3 has to be in the 3rd cell, but then we already have 3 in the 1st cell. So this is 2, 4 as a pair, which eliminates 2, 4 in the rest of the box or row. This can't be 2, it's 3, which eliminates 3 in the rest of the box. So this becomes a 2, 4 pair, which eliminates 2, 4 in the rest of the box and column. So no 2 here, no 2 here. This 3 eliminates 3 here, so it's 2, 8 as a pair here. This is 3, 7 as a pair here. Okay, so 3 has to be one of these 2 digits, which means 3 in 3 in row 7 has to be one of these 3. Where are the 4s in rows 7 and 8? They cannot be here because of the 2, 4 pair in the box. They can only be in either the 9th position or the 1st, 2nd, and 3rd position. So this is 1, 2, 3, or 9. 3 obviously can't be here. They can't be... Okay, so that's one thing. You can never, if you have a non-1 digit outside of the... if you have a non-1 digit outside of, on this number room clue, you can never have a 1 in the 1st position, right? Because if you have a 1, then that guarantees that it would say that the digit is in the 1st position when that's 1 is there. So that's not allowed. So this can't be 1 here. These can't be 1. 4 has to be either in the 2nd or 3rd positions here, and obviously is in the 9th position there. Similarly, if you can't have this be 7 here. This can't be 7, because if this is 7, that's saying 7 has to be in the 7th position, so this would also be 7, and we'd have a duplicate in the row here. So this cannot be 7, which means this is not high, it's medium. We cannot have 3B here and 3B here, because then that would be repeat on the Renban line. So this has to be 3 here and 3 here, which makes this a 4 and this a 2. So no green here, no blue here. This is 4. 3 is here. That means we are guaranteed no 3 and no 4 on this Renban line, which means it has to be 5, 6, 7, 8, or 6, 7, 8, 9. With a guaranteed 6, 7, 8 here. But that doesn't really help us much. Anyways. One of these is guaranteed to be a 1. Okay. Remaining digits of row 1 are 1, 2, 3, 7, 8, 9. No threes in either of those spots. This is going to be 1 out of 2 or 3. This is going to be 1 out of 2 or 3, which means... So 6 has to be one of these 4. And 6 has to be one of these 4 because of the number of rooms clue. Well, this 2 being 1 out of 2 or 3 and this being 1 out of 2 or 3 eliminates 2 and 3 in the rest of the column, so there's no 2, 3 here. This can't be 2 or 3 because of a 2, 3 guaranteed here. It can't be 1, it can't be 4, so this has to be 5 or 6, but if it's 5, that would say 7 has to be in the 5th position when there's a 3 there. So this must be 6, which makes this 7. That makes this 5. There's no 5 here. It's 6, 7 as a pair. Remaining digits of row 6 are 2, 8, and 9. Interesting. 7 eliminates 7 as a possibility on this Renban line. So this has to be 1 and 7 here, which eliminates 1 and 7 here. This is guaranteed to have 6 and 8. So this must be 1, 7, 5, or 9 here. This can't be 5 because of 5 in the row. This can't be 2, 3, 4, or 5 here, and 1 can't be here because of the number of rooms clue not working for non-1s if this is 1. So this has to be 6, 7, 8, or 9, which means 5. It cannot be 9 because 9 can't be in this row. So 5 is guaranteed to be in the 6th, 7th, 8th position, which means this Renban must contain a 5. So it's either 3, 4, 5, 4, 5, 6, or 5, 6, 7. We don't know. We just know there's a 5 here. Okay. 6 eliminates 6 from being here in this box. And this can't be 3 because of 3 in the row. Okay. 4 is in the 2nd or the 9th position, so this can't be 4. 4 here is in the 2nd, 3rd, or 9th position, which is fine. Remaining digits in column 9. This one of these is 9, so this cannot be 9 here. And we have 2, 3 as possibilities here. That leaves the remaining digits in column 9 as 1, no 2, 3, 4, 5, and 7, 8. Okay. How does this Renban work? So it either has 2, 8, or 9 here. If this is 2, we have to have a 3 on this Renban somewhere, and it can't be here. We also know 3 has to be one of these 3 digits there. So therefore, this would be 3 in that case. Well, if this is 8 or 9, it's either 5, 6, 7, 8 or 6, 7, 8, 9 on this Renban. So 7 can't be here because of 7 in the box. So whereas a 7, it has to be here. So this is either 3 or 7 here. That's interesting. So 4 cannot be in the 2nd position. So this is 3 or 9. So either this is 3, which makes this 9, which makes that 4, or this is 7. I don't know. Any of those could work. This can't be 4 or 5 because of 4 or 5 in the row. So we know 1 out of 4 or 5 is here because there's no other place for it in column 9. This must be 1, 6, 7, 8, 9 here. It cannot be 9 because one of these two is 9 in for the number of rooms clue here. Okay. If we have 2 and 3 here, we need a 4. And so this would be 4. And this would be 1 or 5 here. If we had 8 and 7, it could be 5 and 6 here. Or 9 and 7. It could be 6 and 9 here also. Or 8 and 6 here. Those are the possibilities. Okay. This can't be 2 or 7 because of 2 or 7 in the column. What else do we have? So what happens if this is 3, 4, 5? So say this was no 6 here. Well, you'd have 3 here with 4 or 5 here. But the 3 here would eliminate 3 from being here. So then this would be saying the number of room clues, one of the 6's has to be in the second position. But because we have 3, 4, 5 here, that's not possible. So this cannot be 3, 4, 5. It has to be either 4, 5, 6. We have with a guaranteed 6 here, or 5, 6, 7. So 6 either way is guaranteed to be here. That means this can't be 6. This cannot be. The 6 in this box has to be in one of these two cells. So therefore it must be in the second position, which eliminates 2 in the rest of the column. This can't be 2. It's 9, which makes that 3. That means this can't be 3 there. It's 7. 3 is saying that 4 has to be in the third position. So that's 4. This is saying that 4 has to be in the ninth position here, so that's 4, 2. 9 eliminates 9 here, so it's 1 and 9. Therefore, 9 cannot be here. Oops. What happened there? This can't be 9. This can't be 7 because of 7 in the row. That can't be 7 either. And 9 eliminates 9 from being here. This is 5, 6, 8 as a triplet, which eliminates 5, 6, 8 in the rest of the box. This can't be 5. It's 1. This can't be 1, 5, or 9. It's 7, which makes this a 9 there. Okay, 5 is guaranteed to be one of these two digits, so this can't be 5. This 7 eliminates 7 here, so it's 6, 8 as a pair in column 2, which eliminates 6, 8 in the rest of the column. This can't be 6 or 8. It's 7. No 7 here. Remaining digits are 2 and 5 in row 8. And this can't be 5 because it can't be 1, 2, or 3 here. So therefore, this is 2 and this is 5 there. 2 eliminates 2 here. 7 means this can't be a 4-length rem band with 2 here. So this is 8 or 9. So this cannot have 1. It cannot have 4 there. We are guaranteed. So this is 8, 9 pair, which eliminates 8 and 9 in the rest of the row and box. So this can't be 8 or 9. It's 2. This can't be 8, so that's 1, 4, 5, 7. This can't be 9 because of 9 in the column. We are guaranteed one of these is a 6. So we have a guaranteed 6 in positions 4 and 5 here, which is in columns 5 and 6 here. We have a guaranteed 6 here on this Ren band to form a valid Ren band in columns 5 and 6. That should eliminate 6 in the rest of columns 5 and 6. So this can't be 6 here. This is 8. This can't be 6 or 8. It's 5, which forces this to be 6, which makes that 8 and 6. Okay, 8 eliminates 8 in the rest of the column, so there's no 8 there. 7 eliminates 7 in the rest of column 8. So this can't be 7 there. It's 4, 5, 6 as a triplet, which eliminates 4, 5, 6 in the rest of the column. So this can't be 6, it's 8, which makes that 1, which makes that 6. 8 eliminates 8 here, so it's 9, which makes that 8. Therefore, we cannot have another 8 on this Renban line. 7, 8, and 9, and 2 eliminates 7, 8, 9, 2 here. Remaining digits of column 8 are 1 and 3. 1 eliminates 1 in the rest of the column, so this can't be 1. This can't be 1 here. This is guaranteed then to have a 7. Where's the 8 in column 1? It must be here. That eliminates 8 in the rest of row 1. So no 8 here. 2 eliminates 2 there. So that's 3 or 9. 2 here is guaranteed because one of these must be 6 here. So this cannot be 2 here. Where's 2 in row 1? It has to be here. So that's 2. 5 has to be in the 8th position, so this is 5, which makes that 4, which makes that 6. These cannot be 5 anymore. This is 2, 4 as a pair here, which eliminates 2, 4 in the rest of the column. And it's saying 6 has to be in the 2nd position and the 4th positions here. So this cannot be 6 here. 6 here eliminates 6 being here. This is saying that then 6 has to be in the 2nd position. 6 has to be in the 4th position. So this is 6. That eliminates 6 from being here. So this is 5, 8, 7, 8, with 6 to be form a Renban. 6 eliminates 6 here, so it's 7 and 6. 7 eliminates 7 here, so it's 5 and 7. Okay, we have, where is 7 in row 1? Can't be here, can't be here, can't be here, so it must be here. 2 is here, which means this cannot be 1, 2, 3, so this must be 7, 9, and 8. That leaves this as 1, 2, and 3 there. We have 8 2s. We know where the last 2 has to be. It has to be there. Do we have enough 1s? Not particularly. We have a 7, 8, 9 triplet in row 2. This can't be 7 or 8 because of 7, 8 in the box, so this is 9. This can't be 7 because of 7 in the row, so that's 8, that's 7. We have remaining digits of row 3 are 1, 3, 4, and 5. This can't be 4 or 5, so we have 1, 3 here. This is 1, 3, 4, 5, but no 3, 4, 5 here because of 3, 4, 5 in the column. So that's 1, which makes this 3, which makes that 1. 1 eliminates 1 here, so it's 9 and 3. This has to be 4 or 5, but can't be 5 because of 5 in the column, so that's 4, that's 5. Apologies, I need to grab this. I'll be right back. Okay, and I'm back. Sorry, I had to take a phone call. It was kind of important. And let's continue with this puzzle. This one eliminates 1 here, so that's 3. We have 1 left in column 7, so that's 1 there. We have 8 1s. We know where the last one has to be. It has to be there. We've already done all the 2s. 3s, we've got all 9 3s. 4, we have 8 4s. The last 4 is there. We have all 9 5s. We have all 9 6s. We have all 9 7s. So it's just 8. And in column 6, we have to have an 8 remaining here. So that makes this 9, which makes that 8, which makes this a 9. And that's a solution to the puzzle. Pretty cool, actually. I enjoyed how these numbered rooms interacted with the Renban lines. And I guess the Renban lines interacted with it themselves, which was kind of interesting, too. That was kind of cool. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.